Welcome to the lair of the Batty Boffin.
Hi there Batty fans, speed, distance and time with the Batty Boffin again. And this time we are looking at velocity time graphs. Now in earlier videos we've looked at distance time graphs and the two are very similar but different. Don't get them mixed up. They both have time along the bottom, mine's measured in seconds, but this one, instead of having distance from your starting point up the side, has got velocity up the side, and I've got mine in meters per second. I'm using velocity there. Sometimes we use the term speed, and they are largely the same if we're talking about just going in a straight line. In physics we tend to refer to velocity more because that's the correct term, but quite frankly if you're just going along a straight road, speed is the same thing, provided you're not turning any corners anywhere. So speed time, velocity time are the same thing. Distance time graphs, different. Now, quick recap. In a distance time graph, how did you show a steady speed? Pause the video and remember how you did that. Hopefully you said a straight sloping line. On a distance time graph, a sloping line like that indicates a steady speed. That's a lowish speed, that's a highish speed. Okay, so the steepness of the line showed the speed. On a velocity time graph, it's very different. Here, we have you at time 0 travelling at 3 meters per second. 15 seconds later, I'm still travelling at 3 meters per second. So this bit of horizontal line shows a steady speed. I'm travelling at 3 meters per second consistently for 15 seconds. On a distance time graph, a horizontal line meant you were at rest because it was a distance time graph, which meant your distance didn't change over time. That would be at rest. On this graph here, how would you show somebody being at rest, not moving? Pause the video and show me how you'd find that, please. Okay, person at rest would be shown by a horizontal line at the 0 meters per second. If you are at rest, your speed is 0 meters per second. So it's a line down here that shows somebody at rest. A line here, even though it's horizontal, does not mean you're stationary. It means your speed is stationary. Your speed hasn't changed, rather than your distance hasn't changed. So here is a constant speed. It's kind of middleish constant speed. That's a high constant speed, a low constant speed, and a kind of middleish one. So here's a kind of middleish constant speed. Here's another constant speed, but it's higher. So what does this section represent? Hopefully you said an acceleration. A sloping line on a velocity time graph shows going from one velocity to a different velocity, which is an acceleration. Please note, by the way, going from a higher one to a lower one, like this, that is also an acceleration. In physics terms, an acceleration can be a positive number or a negative number. It just means a change in your velocity. So it can be getting higher or getting lower. In common language, we often refer to that as an acceleration and a deceleration. Okay, so in common language you can call them those, but in physics actually they're both considered an acceleration. So when you see formulas like F equals ma, a is the acceleration, it can be a positive one, getting faster, or it can be a negative one, getting slower. So from a velocity time graph, it's very easy to work out what somebody's velocity is. Yeah, just read it off. That's 3. That's 5. But how do we calculate the acceleration for that? Well, in earlier videos we looked at formula triangles, speed, distance, time, and we looked at another one for acceleration as well. So pause the video and see if you can write that down, please. Acceleration is equal to the change in velocity, which we write as delta v, over time. Acceleration is the change in velocity over time. So we can do that with this section here. If I draw in my little triangles, just like we did with the distance time graphs. The change in velocity is the height of this triangle. It's that velocity is 5, that velocity is 3, so that change in velocity is 2 meters per second. And the time is from 15 to 25, so that's 10 seconds. So that means that my acceleration is the change in velocity over the time. 2 divided by 10 is 0.2 meters per second squared, because that's already a meters per second and we're dividing it by seconds again, so it's got seconds squared on the bottom. Don't worry about the units too much, so some of the early videos talk about that a little bit. So 0.2 meters per second squared. Great, hope you got that. Now what's going to happen is I'm not going to wipe down the board, I'm actually going to do the next section on the computer, so you've got some very nice graph paper to work with. So pop back in a minute and we'll have some ones for you to calculate. Right, here's some for you to try then. There's my lovely graph paper, and on it you can see I have time along the bottom, velocity at the side, measured this time in miles per hour. So we're doing like a car journey here. So we have 3 sections, section A, section B and section C. For each section I'd like you to state whether it's a steady velocity or an acceleration. If it is a steady velocity, I'd like you to state the velocity, and if it is an acceleration, I'd like you to calculate the acceleration, please. So off you go with that. Right, here we go. Section A starts off at 0 miles per hour and changes to 30 miles per hour, so that is clearly an acceleration. Section B is at a steady speed, and section C is also an acceleration. It's getting slower, but I'm still going to call that an acceleration because it's a change. So for section A, we're going to draw a little triangle, and remembering that acceleration is change in velocity over time. Change in velocity is found by the height, here it is, and here's the time. When we divide them, here's our acceleration, and this time it's in miles per hour squared, because miles per hour, and that's hours. For the second section we have a steady speed, and that's quite easy. There you go, hope you got that one. For section C, again we're going to draw our triangle. It doesn't matter if you draw it up to the right or down to the left, both are fine. The change in velocity, this time is a negative number because we're getting slower, okay? So the height of this triangle is a negative number, it's sloping downwards. And there's the time, again in hours. Not quite such an easy division this time, but you can always use your calculator on them. And there is our acceleration in miles per hour squared. Slightly odd unit, but there you go, miles per hour divided by hours. And it's a negative number, as you can see, because we're getting slower. Okay, hope you had fun with that. I'll see you next time, Batty fans.